Another example that will show you the use of linear array is creation of a family line-based. It's in that whole generic models group of templates, and we have one that it's called line-based. Let's see what is inside this template. We have, as the name suggests, a line of a certain length. Then in the project we will indicate the starting point and the end point, and something will happen along that line. In our case, we will create array ornamentation called dentils in architecture. To do this, I create a new generic type family for myself, which I will load in a moment. So I will move on to the view left and create simple extrusion with a height of, let's say, 300 millimeters. I won't focus on any specific dimension, it's just an example. I will simply try to create a kind of ledge sweep. You will see what I mean in a minute. I would like it to be symmetrical on both sides here, so I enter some negative value for this extrusion. I save it as a separate family and call it decoration. Let's load it into the family. Now I would just like to place it with some spacing. Although we were about to parameterize everything, and now I would like to align a side plane to the initial point at the end. And I will add it in a moment by creating an array. I create an alignment, and at this point see that I lock to the side wall of this geometry and will close it. Now I choose the array again with the setting of last, linear mode. I enter a value for myself, some sample value which we will later parametrize, and I create an alignment to the left. And remember always to close the padlock. Now, as with the ladder example from the previous lessons, I parameterize the number of elements in the array. And similarly, I can make a spacing parameter. Existing length parameter will be included in a formula in this parameter n. I have to make sure that all of the parameters are set as instance, as length is also the instance by default, which is logical because we will simply draw a line by clicking 2 points in a project. The length is then always different for each case, for each line that we will draw. So I immediately change this parameter to instance as well. So all of them are set as instance parameter. Otherwise, Revit will throw an error for us. We can group those parameters. We have everything under dimension or move it to constraint. It doesn't matter really. And I, for example, will increase the spacing to 500. And let's enter the formula. We select first point and the last one. And at this point, let's see that this component has collision with the wall. So the order in which you click these lines also matters. So if I would like these stencils to appear in the correct side, I would have to point first the right point, and second would be the left. Having a line in such a template, we can also easily create all kinds of sweeps. I can select a path and create some profile. And we can also model these types of objects in Revit. Let's see that the spacing of this object does not perfectly coincide with the value that we introduced in the family types. If I dimension the distance between the details, it falls within a certain range. Let's see, if I change this every time, it increases or decreases for us within a certain range. The reason it is happening is that it always looks for the full integer. So if we divide the length by the spacing, sometimes it gets rounded to the full value. So we have some leftovers that will be used in the array. So let's be aware of that. And if we want to be able to read this value inside the family, we can use something called reporting parameter. I create a dimension line for myself. I create a new parameter out of it, call it instance, and activate the reporting option. This parameter cannot be used in any formulas, and in fact, as the same name implies, has only an informational function. So you see that this value is blocked from editing, and then the designer who uses it in the family already in the project may just click on it and read the value. And you can see that at this point here we have a difference of 2 millimeters between the assumed one and the actual one. If we wanted the spacing to actually be exact as the entered value, we would have to use not the last array formula indicating the last point, but pointing to the next point. So I will ungroup this again, this element, it is pinned here. Let's make a new array now. This time activating the second option. Let's do 10 of those. I enter value 500. And you can see that this array will work much better. So let's connect the previously created spacing parameter with this dimension. Here's a warning that this type of link between geometry can cause issues in the future, but I will ignore this because it is a very simple case, but it's good to be aware of that. We will test it in a minute. Let's say we have a 700 value now, or 500 or 400. This value will always be constant. Now I select such an array and connect n number according to this formula. This spacing will be fixed value now. It is now 500 millimeters, you see. It's always good to double check everything in such cases, so I'm doing it right now. If I want this array to start at some distance from this first point, I draw additional reference plane. I create dimension. I can also lock it, although here I don't have to worry about it so much because the starting point will always be there. And now I simply move the first element of the array removing the existing constraint first. which were blocking the operation initially. Now I just align and move it and define the first location of the object. Due to this offset, now the last element can stick out a little bit. So I can subtract some initial value, 270 millimeters, from the formula. Here I have to subtract, of course, introducing parentheses beforehand to maintain the correct order of mathematical operators, and in this way also control the geometry.